When people hear neural networks, they often imagine something mysterious or even human like. In reality, a neural network is just a structured way of processing your information. At its core, a neural network is made up of layers of tiny decision makers called neurons. Each neuron takes in numbers, runs a very simple calculation, and passes the results forward. On their own, these neurons are extremely simple, like Lego bricks before you build anything, full of potential but not very useful yet. What makes neural networks powerful is how those pieces are connected. Information flows through the network in stages. The first layer receives raw input, like pixel values from an image or values that represent words. You can think of this as turning real world information into codes that the network can work with. The final layer produces an output, a classification, a score, maybe even a decision. That's your Lego castle. The same simple bricks now built into something useful. During training, the network makes a prediction and compares it to the correct answer. If the prediction is wrong, the network adjusts the strength of its internal connections. Those connections are called weights. A weight controls how much influence one neuron has on the next. Some connections get stronger because they help produce the right answer. Other gets weaker because they lead to tiny mistakes. This process repeats over and over. Each pass makes the network slightly better at the task it's being trained for. Neural networks don't understand concepts the way humans do. They don't recognize objects or grasp meaning. They simply transform numbers, step by step, until useful patterns emerge. That's why neural networks are so effective for things like image recognition, speech processing, and language models. They can take very complex inputs and gradually reshape it into something a machine can act on. So, big picture. Neural networks are the structure that makes learning possible. They are the frameworks that allow improvements to happen through small, repeated adjustments. But let's be clear, neural networks are not intelligence. They are tools, powerful ones, but still just mathematical systems. And that raises an important question. If neural networks are just number crunching machines, how do they handle language, something fluent, contextual, something deeply human? That's where large language models come in, and that's coming up next.